If you're anything like me, you build applications that must at times stream data. And every time you do just that, a familiar thought starts to creep in. Wow, I definitely thought this would be easier. Also, if you're anything like me, you don't really know what Apache Pulsar is or how to get it up and running. As such, I'm very excited for this next talk. Our next presenter is here to hopefully help me keep those creeping thoughts about streams at bay, and is someone we're very excited to have with us at ETE. Developer advocate at Stream Native, Tim Spann. Take it away, Tim.
Thanks for that great introduction. So my talk is deep dive into building streaming applications with Apache Pulsar. Usually I'm sitting across the river in sunny Princeton. Today I'm down in Virginia. I wish I was there in person. Hopefully next year we'll all be in person. We'll have a pretty awesome talk. I've been covering a lot of different things over the years. The sweet spot that I found for streaming in the last, say, 9 months or so is a combination of Apache Flink, Apache Pulsar, and Apache NiFi. They really solve all the different types of streaming problems without, some of the heavy lifting that we used to have to do before. I think today is the day. If you haven't done any kind of streaming apps, today is the day to get it started. I work at a company that helps people, get up to speed with Pulsar. We do free training. We have a free forever tier for people just starting out. And if you go to the Academy, we have a thing where you spin it up, learn how to use it in your language of your choice. And we give you a visual code with a little cluster you can play with. It's a great way to get started, see what you think of Pulsar. Every week, I put out a little newsletter that talks about different apps and demos and new releases, everything around streaming, and a bunch of different tools I find that I like. If you're on LinkedIn, which you probably are, give it a scan and we'll get in there. I'll make sure these slides are posted to the Slack group so you'll be able to get in there so you don't have to screen print everything or take a lot of notes. You'll get all these slides. You get all the GitHub with all the examples, all the source code, all the contact information. So there's nothing that you have to, write down or take notes. Pretty easy to do. So that Academy Stream Native I mentioned before, free, get in there, sign up. You could try out a bunch of different courses with included labs to spin up an environment for you that you can use for 3 days. And when you're done, you could just start another one if you weren't done yet, or just use the free tier. And we've got other training. If you get past that and you say, hey, yeah, it's time to go to production, get some training there. But why do I want to get trained in Pulsar? What is it? What does it do? It's kind of unique. This statement really says a lot, but doesn't say anything. Cloud native, which is table stakes today. You better run on every cloud as easily as possible without any heavy lifting. Messaging and event streaming, two different things. I think that that confused even me. I've been doing JMS, RMI, all that kind of different messaging for years with RabbitMQ, ActiveMQ, lots of different things. That messaging and things like Kafka and Kinesis, not the same thing. What's unique with Pulsar is you could do both, depending on how you want to consume that data. But we'll get into that in a minute. Let's why might you want to learn Pulsar? Besides it being one of the newer ones, it is that unified way to do messaging. So it is, that old style messaging, which has a lot of use cases, word queues, just trying to send messages around. A lot of times you don't want things in order. You want them as fast as possible, or you want to distribute messages to lots of different people who are going to consume those events and run with them, do something. So we'll show you lots of different things there. Guarantee you get your messages. It's pretty important. I mean, unless it's logging where you're spitting out a lot of stuff, you want to not lose any messages. Resiliency, you don't want things to be crashing. You don't want to lose parts of your infrastructure for no reason. It's set up to be very durable, lots of layers. Everything scales independently. This is a big one for the cloud native. Compute and storage are in separate layers. They scale up separately, can run them in completely different pods or containers or VMs or servers, run in a mixture of different hardware, whatever your needs are. And the scalability, you want to say infinite scalability, and that sounds like buzzwords. but we have a couple of very large users in Asia that are scaling up to petabytes of streaming data for a day, billions of transactions. People like Flipkart and Tencent are pushing a lot of data through Apache Pulsar. So we haven't seen that top end of scalability. And with that separation of computed storage, support for lots of different infrastructures, support for tiered storage out to cloud object stores, really, well, I'd like to see someone find that limit. It's big enough where the limit is probably affordability for even someone like Tencent. You know, once you get past 5, 10, 20,000 servers, how big do you need to go? Some of the things you could do with Pulsar, building microservices, because we can host Java, Python, and Go within the platform, either within our brokers, if you're just running simple infrastructure, or we have something called function mesh that are running Kubernetes and have a more AWS Lambda style feel, serverless computing. This is a great way to orchestrate between microservices, keep them disconnected, very loose coupling there. And it doesn't matter which language, because almost every language is supported for messaging with Pulsar. I can easily communicate between different microservices, regardless of where they are, regardless of language. Besides our native support for a ton of different languages, we support other protocols. So if you can't find a way to communicate between your services, you're going out of the way to find that. Real-time apps are going to become more and more important because a lot of data you need to make decisions within seconds, minutes. By the time it's an hour old, it's already too late. If I'm getting a message from a sensor on a train that something's overheating, I can't really wait for a batch report in a day or an hour. Something's going to go wrong. Things like continuous maintenance, cybersecurity, and a lot of things these days. If you have an app, no one wants to wait for the next day to find out, am I approved for a loan? Is this thing working? When's my internet coming back up? You need to know right away. Tiered storage, because most people are running in some kind of cloud, and even on-premise Kubernetes now, you have different object storage. Being able to store as much as you need. So if I need to rebuild, whatever system I'm feeding, I can go back to the original message. And if it's in tiered storage, it's transparent to you, regardless of the interface within Pulsar. So if I use a regular consumer, or I use one of the 3 SQL engines, very easy to access any message, regardless of how far back it is. It'll handle that for you automatically. Obviously, tiered storage is a little slower than, on-premise, sitting in an SSD drive somewhere really close to your messaging. But at the scale that you need to do and, different use cases there, really doesn't matter. Asynchronous, so you got everything disconnected. I send the message and it's off, and whoever wants to read it can read it. What's nice with the Pulsar setup, it could live there forever. And, lots of different people can read it. Pulsar handles the offsets and where clients are within a read. So you don't have to worry about managing that yourself within your application. Again, keeping things simple. Resiliency is in there because of multiple tiers have isolation. They also have other options. Say you want to store your metadata in a different data store like etcd, we support that. Each tier manages just what it needs to do. It's not, it's not overloaded. Storage does storage, and it does it well, it partitions it, does all those kind of fun things you need to do. The broker just handles messaging. Metadata is handled in its own place. Keep things isolated so you're not doing too much in one layer. There's a lot of different people using Apache Pulsar. This is a small list. Again, pretty big companies, big use cases. Some of the use cases will be things like, I want to only have one messaging engine. Most people in their enterprise might have RabbitMQ, ActiveMQ, IBM MQ series, Kafka, Kinesis, and some legacy message. You could have 14 or 15 of them and to have them try to cross message. Maybe you have a gateway somewhere. Maybe someone writes an app that consumes from one, pushes to the other. That's not clean and not sustainable, especially as you're moving to different cloud native environments. So we support most of those libraries. So you don't have to rewrite those apps. Use the library and app you have already. Just point it to Pulsar. We'll be your MQTT broker. We'll be your AMQP broker. We'll be your Kafka broker. We'll be your WebSockets broker. Just send that data. FinTech is a common one for us because of large data volumes, the needs for scalability, to be able to geo-replicate around the world, regardless of different availability zones, different clouds. It's very easy to set that up. Doesn't require any specialty when you set up the topics. So if you decide to add geo-replication later, you don't have to rebuild everything you have. You don't have to repartition. The data, when it's stored, is stored smartly. It never has to be rebalanced. Again, reducing that administrative workload, because I know I don't want to have to work on setting up different kind of complex management, rebalancing, or busy work that you have to do to just keep it running. Having come from the world of other messaging systems before I joined Stream Native, that was a lot of workload. Another kind of key feature that I sometimes blow past because I'm so used to it now is multi-tenancy. To be able to have different layers, and I'll show you within the system how that works, having multi-tenants in one cluster. So I can have different companies, different lines of business, and you don't have to worry about security. I can only access a tenant if I want, just the namespaces and topics underneath there. It's a very good way to isolate out different companies if you're hosting them in one environment, or different applications. It solves a lot of issues there with security and management. This lets us run hundreds upon hundreds of thousands of topics without having, you do a list on your topics. You don't want to see 100,000 come back. With the different tenants and namespaces, you could break them up. It makes it very easy to have, 20 for my group over here, and I could have simple names. I don't need to have, 100 character names with weird symbols in them to try to make them unique. That's just part of the puzzle. Lots of different people can consume the same data. So even if it was born in a real-time system, say it comes off an ATM, they're using MQTT, comes into Pulsar, I don't have to use the same protocol to read it. So I can have an app read it Kafka native. I can read it Pulsar native. I could read it MQTT. I could read it WebSockets, REST, lots of different options, lots of different libraries that let you use different languages. So if you want to do an app in C#, you want to do one in C++, and Python, and Go, and Scala, and Haskell, and Rust. Most of the languages are there in the native libraries, or you can use libraries from those other protocols. And for things like transaction support, fraud detection, machine learning, obviously things like Spark and Flink are first-class citizens. We don't try to reinvent the wheel here. We work with those communities very closely and those companies to make sure we have native fast connectors to do that. For Flink, I just set up a catalog, and then all my topics look like tables, very easy to manage. Performance and security from the beginning. Pulsar came out of Yahoo as their solution to handle every message within their entire infrastructure, regardless of what it looked like, regardless of where it was going, just to have that one thing make it easy. Now, I guess table stakes and the original thing you got to think of is, what am I sending around? Some people call it a message or an object or an event. Well, let's settle on the term message. That's the basic unit that's traveling around. And this has a value or a data payload. It is raw bytes. So if you want to split up an image there that's UU encoded or MIME encoded, you could do that. One of the nice features of Pulsar is it can split things up and batch them, different ways to store things if you needed to push through big data. Is that a great idea? It's a nice idea to put through a solid record in one message, and that is what I'll recommend. But if you had to do something else based on the way it's going, you could do it. There's certain ways to batch things. But to keep it simple, think of one record, one message, have a key on it. It's not required, but for performance, for partitioning, for compaction, for searching for it. If you put that message in there and you want to debug later to say, where did that message go? Did it go where I expect it to go? If you're trying to debug something, did they get it? Did they get it twice? Those sort of things. You could add any properties for metadata that you might want, key value pair of things like, okay, when did someone produce this with my own special timestamp, or a key that gives me some kind of maybe physical location. I'm in the mini conference room in Williamsburg, Virginia at this GPS location, add that. Give things a name, whoever's producing that message. Again, helpful if we need to do some kind of automatic deduplication, or you need to do it. You have a ordered sequence ID, so you know things are in a sequence, especially if you want to keep them together or there's an order. Again, ordering is up to you if you want it for a use case or don't. What's nice is it will default to when it gets pushed in to allow for sequencing, but if you want to consume it in a non-ordered way, doesn't matter, which is a great feature. Again, we talked message queuing for streaming. They are different. We support both. Queue, again, the number one use for a queue really is a work queue. Like, you have a lot of different apps that can process information as fast as possible. You don't usually care about an order, they're idempotent. Something comes in, do something to it, be done, get the next one. It's a great way to push data through the system fast. Sometimes you do need it in order. Maybe you're doing logs, later you're doing CDC. There's a lot of use cases people have done traditionally with Kafka or Kinesis, and it streams. There's a stream of ordered data. Maybe you need things exactly once. Maybe you need them at least once. Lots of different semantics there. We have full support for doing streaming use cases, and even can support Kafka protocol if you want to keep it as simple as possible. So there's a lot of different ways to get data in and out. If it was just the consumer and producer, that's pretty useful. But a lot of times you don't want to have to write those full consumers and producers to get data in and out. You might want to do something like a function. A function is a lightweight bit of code to do some stream processing as events arrive. As your message comes in, do something to it. And what's nice is these functions can work on multiple topics at once. They could output data. They could read from anywhere. You could use any libraries that are native to those three languages. And it is an open system. So if someone decides to write functions in another language, you could certainly do that and then have that run through the function mesh. Right now, Java, Python, and Go is a pretty good set of languages. These can do things like maybe some machine learning classification. I use one for sentiment analysis. I use another one to clean up data as it comes in, routing, transformation, lots of things you could do with these. Think of these kind of like a database trigger. Pretty similar idea. Connectors, if you used Kafka before, you get the idea of these. We do support Kafka Connect as well, but you got sources where you don't have to write code to do it. You set up a little configuration and you could DevOps this to have this auto deployed, have it go out there, connect to say your CDC Debezium system to get table data as it changes, comes into Pulsar, and you can decide what you want to do with it. If you want to write a sync to handle that for you automatically, have it drop into an S3 bucket or drop into Scylla or Elastic or relational database, or even push it out to another messaging system. We could speak a lot of different messaging systems that way. If you want to use Pulsar as your gateway, have it consume this message and then push it out in Kafka. Maybe have a function in there if it needs to convert it a little bit or do some other enrichment. Pretty straightforward. We mentioned all those different protocols. This is an open set of APIs to add your own handlers for different protocols. And they plug right into the architecture, and they're full first-class citizens. So I don't care if you're working with native Pulsar protocol, or you want to do Kafka's or MQTT or AOP, or also RabbitMQ. Turn them on, messages come in. It's stored like a regular message in Pulsar, and I could consume it out in any way I want. So just because someone pushed it in through Kafka doesn't mean I have to read it out that way. So that's a really nice feature. Lets you easily integrate with a lot of different existing systems. You don't have to rewrite all these systems just to take advantage of the benefits of Pulsar. If you want to process things, certainly you could do a little in the functions. You could write your own consumers to write stuff, but there is first-class connectors out there that are really nice for Flink. And I can write traditional Flink streaming apps or Flink SQL. Again, very easy to write these. Same with Spark. You can do Spark ETL, Spark structured streaming, whatever you want to do with your data, whether it's SQL or code. And then finally, we have something called Pulsar SQL, which by just turning on a couple of switches, you enable a Presto Trino engine that queries down into all the topics for you, sets them up. Now, if you didn't set up something that looks like a structured data, it's not JSON, it's not Avro, doesn't have fields, doesn't have a schema, it's just going to show you a couple of fields. Those metadata fields we saw before in that message screen, value, you can see a value there in bytes. Presto's pretty smart SQL engine. And if it's something like JSON, you could have it look like JSON in your query. But I recommend using schemas, and we'll go into that. Schema engine is built in as well, so you don't have to install something else or learn some other thing. Supports all the major schema languages. And again, data loaders is also something you could extend. Right now, it goes to most of the tiered storages. But if you have some of your own engine, you could write one. I've talked to the Scylla people, they might write one. Whatever you might need there. Open source community lets that be pretty easy to do. So that schema registry, part of the platform, you don't have to think about it. If I write something, I'll show you some Java code. I write a class, all I got to do is write a standard Java bean, and I just tell Pulsar, this is what my schema should look like, and it will take that class, pull the fields and types out, and create a schema for me. And I'll just tell it, yeah, I want this as JSON or Avro or protobuf, and that's, again, extensible as well if you want to add more. But those typically are the ones that most people use. And it makes it very easy. So you know what the data should look like, gives you that contract. And it has versioning in there. It makes it so even though it's bytes floating around, I know what they are. When it goes into Spark, it looks like a table. When it goes into Flink, it looks like a table. When it goes into Pulsar SQL, it looks like a table. And when I read it out in my Java class, it comes in as a Java object. I don't have to do some kind of deserialization or something on my own. And again, what's nice, these schemas have clients for other languages. So I can have Python schema come in, Java read it. They all see it as just the same thing. It makes it pretty easy to work with, systems where you don't have all one language. It would be nice if everything's the same, but that's not the real world. So we support lots of different languages there. Again, with those different protocol handlers, this is an example you could see. It's the same as the way the native Pulsar works. So you don't have to worry, is this some kind of hack or some kind of code that just kind of translates a little? You put a full implementation in there. So, you could trust this to be a real MQTT broker for you, a real Pulsar one, a real Kafka one. Makes it pretty straightforward. And the data comes into the system. Very easy to manage. It looks like every other Pulsar message. Bookie is part of Apache Bookkeeper that handles storage. Zookeeper layer now is extrapolated. So you could do Zookeeper, RocksDB, and etcd. We're adding more. If you have some suggestions for different metadata stores that you'd like to see, post a comment or tag me on LinkedIn or somewhere else. Those three seem to be the most popular, and we'll add more as need be. Same idea with Kafka. Again, you could see all these on a really big one if you want them all on at once. It's really, you download a NAR file, or Stream Native will do it for you, and you set like 3 lines of configuration, what kind of security you want, and then that's just plugged in. Now your cluster speaks other languages. It's a really nice feature that very helpful, whether you're deciding to migrate everything to Pulsar or you just want Pulsar to be able to exchange messages for you. And then maybe at some point you decide, yeah, maybe I just live with one messaging system. But in the meanwhile, Pulsar as a gateway is pretty nice. Very full support and gets an easy way for maybe move all your messages up to a certain cloud or between clouds. Pretty easy. Pulsar SQL is just a nice feature to have. Now, this is a little different. I'll tell you the difference with why we have Pulsar SQL, Spark SQL, and Flink SQL. They're all SQL against the data in Pulsar topics, but Pulsar SQL is a nice way to see what's in that topic right now. Remember, with real-time systems, right now changes really quickly. Right now is a point in time. Okay, these are the 75 million messages in there now. You know, you wait a second, there's more, but I just want a snapshot. Let me see what's in there now. I want to do a query, see what data is there. I could sort, join data, do maxes. It's a very fast engine. I could use regular SQL tools here. There's JDBC and ODBC connectors for Presto. I can pull it into a Zeppelin notebook. I can pull it into Jupyter notebook. Very nice way to take a look at messages without maybe, you know, it's an analyst and they don't really have to know how to do Java plus writing a consumer. They could just get a SQL prompt, write some queries and see what's in the data right now and as it changes. So that's a nice feature. This is kind of the overview of everything in the world I want to do with Pulsar today. You know, it could be a lot from, you know, buffering data before it gets somewhere. You know, maybe I can't handle the full stream of data right now for my system. Maybe it's on pause. You know, it can live in Pulsar forever until it needs to come out, and it can batch it up into chunks if that's how you need it. Can route it to wherever it needs to go, different clouds, different syncs, different engines, aggregate data into maybe you just want the maxes or the sums or the counts, add new fields to it, do lookups, add machine learning to it. I add sentiment analysis to my real-time chats, replicate data between different clouds, different clusters by just turning on geo-replication. And you can pick it for a whole namespaces, whole tenants, just topics. And there's no heavy lifting there. You don't really have to worry about it. The fact that we have the offsets and everything like that in the broker level makes it a little easier. You don't have to worry about what individuals are doing. You can deduplicate data as it's coming through the system. And obviously you're decoupling all these different systems from each other. They don't have to know where the data came from. They don't even have to know the same protocol. Makes a very nice way to distribute data at scale. We touched on functions a little bit. I'm really liking these. It's a very easy way to add some functionality without having to add some heavy lifting. You write it in Java, Python, or Go, press a button to deploy it, or use a very simple script. You can run in Kubernetes or Docker, wherever you need to run these. What's nice is one little function can handle a bunch of topics in, and they could do things like, okay, look for nulls, look for something that we have to translate. Maybe you have some custom logic that needs to run against every message, looking for data that someone might try to steal or must be protected. You put that there. This is maybe where you'd want to add something like a security filter of your own. Very easy to run machine learning models here. Pulsar also can, you know, it can be this massive server with all these connections and sources and syncs, but it could also run on a Raspberry Pi or a little edge gateway. And you could use this to get messages and replicate them or sync them out somewhere else. What's nice is I could deploy machine learning models. My friend David, who wrote an awesome book on Pulsar, which is available for free in PDF, it has everything in it. He's got a nice use case of pushing machine learning models right to an edge. So you can have those models updated and deployed and have that executed as part of a function. And then whatever's coming out can be the result of that machine learning model with maybe some of that input data combined, or that can go out on separate topics. It's built in to send your logs to a topic. So again, logs are live events. I could do processing on them. I could send them to other systems, make sure they get to Elastic or to a dashboard or InfluxDB, however you're Prometheus, wherever you're handling errors, messaging, and logs. And if you've seen some of my posts before, you might have heard that I like Apache NiFi. I was able to help the community here get this connector put into production with full support from us in Cloudera. You can get it from Cloudera distribution if you're running their stuff. And if you're just in the open source, just go to this link, download it, and NiFi can read and write Pulsar data very transparently, very easy to do. And that whether you're doing things as records, if it looks like a record or it's some kind of binary data, we got connectors to consume and produce those. Very easy to set up, no heavy lifting. It is a great way to get your data into your system very easily. Of course, I was trying to wait till the last minute to update this slide because magically, while I'm on vacation, we got 2 new releases. So there's a 2.9.2 and a 2.10. 2.9.1's been out for a while and is very solid. Maybe you do that one. If not, just go to Apache, Pulsar Apache org, figure out which version you want to do. The new 2.10 has support for RocksDB, so it's a little slimmer for your standalone. Standalone's when maybe it's just running on the Edge Gateway, maybe you're using it for development. If you want to do it the simplest way, I've got an old 1U server, I run it this way. It is the simplest, very easy to do, and it supports all the features. It's good, especially if you want to follow, maybe you want to be a committer, start building your own. This is a good way to do it. Obviously, Docker is fully supported and a great way to do it as well, especially if you don't want to dedicate that infrastructure. This is a nice way to do it. And again, supports all the current versions, whether it's 2.9.1, 2.9.2, 2.10. And you could run it in our cloud. Again, we have a free tier, and depending on who you are, you can get some extra credits if you want to run a bigger cluster. But even the free tier, you can push through a lot of messages. I mean, for small app, you could probably, that might be all you need. Also, obviously, like we mentioned, cloud native means, yeah, we run in Kubernetes. And what's nice is we give you the Helm chart, we give you the operator, give you all the details on how to do it. It's pretty straightforward. We'll be at KubeCon in Spain next month. If you're going to be there, it's going to be nice. Say hi. It will show you it running in the full environment, and it's pretty straightforward. We're also working with a couple of vendors to make sure that that'll be in, things like OpenShift and other distributions there. Now, I talked about multi-tenancy. It's pretty simple to use. If I'm logged in and have all my security here, I could do that through the Stream Native console. But if I want to script it pretty easy, or I'm just exploring as I'm learning, you could use the admin command line interface to do it. I can create a namespace under a tenant. Again, every tenant can have as many namespaces as you want. It's a great way to keep your data laid out cleanly. So oh, okay, Tim's meetup that he runs in Princeton, well, all the topics he uses are under there. Makes it easy if you need to rebuild it, back it up, all those sort of things. Everything runs pretty straightforward. These can all run interactively, or like I said, it's scripted up in a DevOps, very easy to do. They also have a REST API if you don't like using command line tools and you don't want to use the online manager for Stream Native. There's also one called Pulsar Manager that's fully open source. That's not from Stream Native if you want to use that one. If you want to use, do Python, Python is a really easy way to communicate. I've got a bunch of examples out there, and I've got it running on my Raspberry Pis, which has been a nice way to get messages very quickly into Pulsar. If your environment has a binary we've already built, you just do a pip install. If not, you'll have to install C++, which is not the most difficult thing in the world, but that'll tell you why it's fast. It's using the C++ library underneath. It's very easy to connect to a cluster. You only have to import one thing, connect to your cluster. If there's security, we have a lot of different security options. So there's a couple extra libraries for those. If you want to do OAuth, you're doing tokens, Kerberos, there's SSL. There's so many different security options. I'll show you an example in Java. It's not that hard. And if you're using the Stream Native one, we show you where to download the things and plug it into your code to, keep you safe and secure. A lot of people trying to hack you now. If I'm just trying to send text, they'll put an encoding on there and just send it away. If you look at this producer, the first part tells me I want persistent messages. What's nice with Pulsar is if you have a use case where just fire this message. I don't care. I'm sending 1,000 a second. I don't need every one. I just need you to get some of them. Push it through as fast as possible. I could turn off persistent, make it even faster. Most people keep it persistent so I can, get it back, rerun it, get it with SQL. But that shows you right in the start of the topic naming. And then the first part, conf here, is our tenant, then our namespace, and then the topic name. Obviously, this is for this conference, makes it pretty easy to do. This is, if I'm going to do one of the security examples, this is how I would do it for OAuth, which is one way to do it for Stream Native. Pretty straightforward. I could just pass all those arguments in along with my private key file. Boom, I'm ready to go. A lot of examples out there, pretty straightforward. If I want to use Avro schemas, it is really simple in Python, even simpler than Java. This is a full Python app that uses Pulsar schemas. Here I'm doing Avro. The only difference is it's the same class. I just wrap it with this Avro schema, and now that's available with that schema when I send that message. And that schema will be attached to this specific topic. So when those get consumed or produced, I'm going to expect it to match that schema. And here I could have as many fields as I want. Very easy to set that up. Here I'm passing in a key. With Pulsar, topics can be partitioned or not, depending on how you want to consume it. It's up to you if you need them. Again, yes, no, depends on things. It's not like Kafka where you have to have them. JSON schema, you see the difference between Avro, JSON. It's one different class, and you just wrap it. Now that data is a JSON schema. It's up to you how you want to do it, what your schema wants to look like. And then when I want to consume this data, with here, if I'm not using the schema, I'm just going to get that back from the message object in the data field. And that's going to be bytes. So if I want to convert that to JSON, I got to do a little work there, use the native libraries for Python to pull those out, as shown here. If I want to send, say, messages to Pulsar via MQTT, I can use the PAHO library, grab my data. I like to put it in JSON. That's up to you what format you want. Connect to that Pulsar server. Again, just like MQTT, I'm going to use that native 1883 port. I don't have to do anything specific there. And topic namespace, just like before, pass in that payload, a couple of MQTT specific things, and we're off and running. WebSockets, a little extra work there because we have to encode the message as part of this payload, but I can do this from JSON in a JavaScript app very easily as well. But this shows you how to do it from Python, pretty straightforward. I point to the Pulsar server as if it's a WebSocket server, and you can see that format there, pretty easy. Tells me I want to produce messages. Again, that persistent. Public is my tenant. Default is my namespace. Topic is my topic. Produce to that. I've got to encode the message in ASCII, then base 64 encode it, and then put that inside of a bigger JSON screen with as many properties if I want in there. Pretty straightforward. And then it's going to give me the results of that in JSON, and I could parse that. The one thing you get back with Pulsar is I can acknowledge every message. If I acknowledge it, then it'll be marked that someone has consumed it. And here, the acknowledgement is, yes, I sent it successfully. Here's the idea of that. You might want to do something with that, store it, use it if you're in a reactive application. If I want to do Kafka, again, I could use, there's a couple different Python libraries for Kafka. I'm using this one. Import the Kafka producer, send that data. Again, Pulsar will run the same exact ports as Kafka if you want. Obviously, you could change those ports to the ones you're happy with, but I just connect to it natively as a Kafka. The library doesn't know I'm connecting to Pulsar. Pick a topic. If I put a topic name without the extra parts that are in Pulsar, it will default to persistent public default. If that's not what you want, fully specify that out, just so you know. Otherwise, you may, where'd my message go? It's under public default, and you name it your topic here. So mine would be persistent public default topic Kafka 1. Again, minor thing, but if you're trying to look for that later, like I was in the beginning, like, oh, where does this go? Does Kafka have its own thing? Did I set one up? That's where it goes. If I want to deploy a function, again, there's a couple different ways, but if I want to DevOps automate that pretty easy, there's a command line tool to do it. And you set a couple of things. I point to my Python code, give it a name, tell me what one or more topics are going to be the input. Where do I want to send the logs? And where does the output want to go? You might not have output. The output could just drop to a file, or you could keep within Pulsar functions. I could keep a state. So maybe I'm just incrementing a state that someone else is going to read, and maybe they'll push out. Again, you don't have to do everything in one function. They can act as a chain and connected with topics. Or I could have a Pulsar function do one thing in Python, then have Spark do a piece, then NiFi, then a Kafka consumer. You can build your change of messaging, whatever language you're comfortable with, or maybe you have other people on your team know different systems or languages. Very easy for everyone to get involved in the streaming messaging pipeline without having to know everything. You can learn a very small bit and add a lot of value to the processing for your team. So a typical function here in Python, we set it up now. There's two options. I can have just a regular Python function and just deploy it. It gets input, output, done. We do have an extra library here that gives you some extra features you probably want. And the ones I want are a logger. I want to be able to log. I want to have access to the context. Also has things like the message ID. It's got access to the state store. There's useful stuff in there. So unless you have a really generic function that's not doing much, use the Pulsar function to inherit from. Set it up this way. It gives you a lot of benefits. Here I wasn't using the schema because I had an existing code send the data in and they don't know about schemas. So I can have a Pulsar function add schema for me. That is a very good use case. Now, we've been showing you Python, Java. Those are great languages. Maybe you want to do Go. The Go client is very fast. I'm impressed with how fast Go is. You might want to do one in Go. It is pretty straightforward to do that as well. And we've got examples out there in most of the languages. Again, this is a very simple app to send messages to Pulsar using the Golang. If you have any questions, please put them in room C. I'm keeping one eye on that one. So just send it there. If I want to do a schema in Java, despite Java being a little verbose, it's not too bad for Pulsar. Pretty straightforward to pick, what data I want to send. You don't have to think about schema. Just define a class to use it. Put that, pick a schema type in there, and it'll do it for you. And you'll just get that data in there. Very easy, whether you're producing or consuming in Java. I have a lot of source code out there available for people to look at. Anything under Spann HW, you'll see a lot of example code. If you have any questions on it, please feel free to reach out. Let's dive into those functions. Again, functions can make your life a lot easier because you don't have to know anything about Pulsar to do them other than deploy them. So I could just write a generic bit of code. It gets an input in, and that's the type you choose. Here I pick string in, string out. I can pick any kind of class, or I can make them void. if I don't need anything coming in and I just want it to be triggered when an event happens. Again, maybe you just need to trigger something to say, oh, I know something landed now in S3. Let me run some security logic, whatever it needs to be. Pretty straightforward to write these functions. Again, if I don't want to do anything Pulsar specific, you could use the built-in Java function. If I want to use the SDK we put out there, again, which I recommend, you get some extra features here, like that context for logging. Context will also let me send new messages to other topics. This is really good for routing, transformation. So I could have things come in from 100 different topics, and I can look at the data or the metadata or do some kind of funky processing that I know of and send them all to different topics, or store them somewhere else. I could call any library. What's nice here is with Pulsar, by default, I can create topics on the fly. So if I'm getting CDC from tables that I've never worked before, I could use that table name to automatically create a new topic and start sending messages there. Again, your admins might not like that, but that's something you can do. That depends on how dynamic your system is. Here, I put a key in, set a property, value, send it away. I could send and wait till it's done, and then it goes away, or I can make this asynchronous. It's as as performant as you need it to be. If you need it to be full reactive coding, there's reactive libraries as well. Again, the speed of these messages coming through is really fast. I like to do the sync call so I get that acknowledgement back. So I could decide, okay, do I think it's good? Say, okay, return an acknowledgement, and then be done. Otherwise, you might have to, get that back in a call. I don't know. It depends on what style of coding you like to do. Now, subscriptions are really important in Pulsar more than other messaging frameworks, because this decides, am I doing a streaming app? Am I doing a messaging app? If I'm doing messaging, my subscription might be shared, which is, me and 1,000 clients are getting these messages, and it's first come. It's like I'm at the buffet. As much as I can pull off that buffet and eat, I'm getting it. So if I happen to have a really fast consumer, maybe I'm going through most of it, and someone's got a slower one over there. Maybe they're only handling a couple. Maybe it's running on a smaller box. And then you go, oh, maybe we need to run more instances or add some more pods. You could decide that. Again, it depends on what you're doing with that information. Maybe you're doing things in order. Maybe you're not. Again, we looked at something similar here. So if I'm looking at a SQL view of my data through Pulsar SQL, this is data as it is right now. I get through Presto. I could do this command line, or I could do any of those tools that connect to JDBC. Show me all the catalogs I have out there. Look at all the schemas in Pulsar. Again, you could use a regular Presto instance you have. Use your regular Trino. Query all the stuff you have, plus the Pulsar data, which is really nice. Here, I could just select from it. I could do order by, max. Got lots of examples there that I did at the Trino conference. Pretty straightforward to do that. Spark couldn't be easier. Again, there's one thing a little different than connecting to other messaging systems is we generally connect to the service URL is where the actual broker is, and it's got an admin where it does all the REST calls. So we give them both of those URLs. Most people are going to have both of these in SSL. Oh, I got a question here. Yeah, okay, I'll wait a couple minutes before I do them, but that's looks like a pretty cool question, so I'll make sure I get to that one from Peter there. So this is example Spark. Here it's very easy if I just want to do Spark structured streaming to grab everything from the topic. What will happen is this will continue running as messages come in, and just here it's just writing it to the console, but I can write it to a file, could write it to a database, could write it to another topic. There's a lot of different stream connectors, or I could use this as a streaming ETL, or I could batch this up if I wanted to, depends on what Spark I want to do here. We work for this one with the Spark community. We jointly work on this adapter. Pretty straightforward. Flink, a similar idea, but not the same. Now, what's nice is the Flink community has taken over this connector, so it's a first class one. You download the full Flink server, it's got that connector. What's cool about Flink is it has a lot of functionality, very scalable, and it can do batches and streaming, but it's streaming first. So when you do a batch, it's really just a slow stream, and it could do state. So I could have massive state. There's a company in China that's using the combination of Flink and Pulsar as an in-memory cloud data lake in the petabytes. And you could do that because the Flink SQL happens exactly as you type it. So it's continuous. So I get everything that's there right now, depending on if I want to look at the first or the latest data, that's up to you. And then as messages come into the topic, they will show up in your query. So that can be just running there. And that could do anything from an insert, could join things together, can insert other type of Flink SQL tables. So these can be joined to HBase, joined to Kafka, joined to Hive, Kudu, whatever it may be, and do that in real time with full SQL analytics. I get do complex event processing with Java, Scala, or Python, which don't have to use SQL if you don't want to use the SQL interface. I like to use SQL because it makes it a lot easier, simpler to understand when you're doing something like SQL. That's pretty straightforward. This is all you have to do to set up your catalog. So say you have 100 Pulsar clusters. That's generally not an issue because we can make one massive Pulsar instance that has all the clusters in it. So you could just connect to that one because we have those separate tenants and namespaces. But say you had more than one Pulsar cluster and you didn't have it under an instance, you can create a catalog for each one and decide what the schema for that is, and you're ready to go. You just query them as if it was regular SQL. And that's really awesome. You could use their Flink SQL command line client, or Stream Native has a Flink SQL console as well. So does Ververica. So there's some other vendors out there. Great way to do that. You can also, once you've prototyped the SQL that works for you, you deploy that as an application, and that'll just get deployed to a Flink cluster and just run for you. What's nice is it's very easy to do things like maxes and mins, order by. This is Apache Calcite. So this is SQL 92. So it's a very rich SQL on top of your streaming real-time data. And you could do a lot with that. Like I said, insert, join things together, limits, left outer join, anything you might want to do with data in real time as it happens, but with SQL. And that could get sent to a topic that automatically gets stored somewhere, or you could use a Flink topic that is a data store and have the data that's the results of this max go into that topic that goes right into a data store. So you could do a lot of real-time processing here, again, with the simplicity of SQL. And if you just want to do things like see what's happening with the data, you could just let these consoles run and see what's going on as it happens. You don't have to worry about, well, what's a Pulsar consumer? Where can I run that? Use your real-time code to do that. Pretty straightforward. Not the most difficult thing in the world there. It's pretty simple there. Building a Spark SQL view. Did I go the wrong way? Let's make sure we're going the right way. Okay, monitoring and metrics. Pretty easy to do. There's a REST interface for all of that. And it's not, it's really easy to go through either the REST APIs or the command line interfaces and get everything you need to know about every topic. You can also preview what's in a topic without affecting where consumers are. Makes it pretty straightforward. When you're done, and say you're done with the app, you run an app, you spin up an environment, run the app, and maybe it's run its course, delete all your things, shut it down, and it goes away. Pretty straightforward to automate all that. Or maybe you're doing something like test containers where you're running the application and then it's done there. Pretty straightforward. I think we may be running out of time, so maybe I should get to this this question I see here. Yeah, I've
Five
got a lot of,
minutes.
how much left? 5 minutes?
Yeah.
Okay, I had a feeling that's where it was. So yeah, all these slides will be available. So let me get into this question here. I think that one's a little more interesting than showing my slides here. Let me get into a normal view here. Okay, so the question is, if I'm refactoring a set of microservices which communicate via synchronous HTTP, what's a way to do that? It depends on if they need to wait for those results there. How is that how they're executed? Are they REST apps? If they're REST apps, they're kind of tied to that synchronous may and their way they're running. If it's a Spring Boot app, I could switch it to the command line runner and add a Pulsar consumer, or I can move those to Pulsar Functions and have it run that way. Here I'm in a Spring Boot app. I could change it to the command line runner. And if I was doing a consumer, I'll just set the consumer here. And when events come in, it'll be run. This one, for example, is a producer. So this is running on a schedule, which you could do with Spring Boot. It really depends on the code. We could use, if they're only sending messages out, and they're using sync HTTP, you could use the REST interface to Pulsar to send your messages out. The easiest rewrite would probably be to switch to the WebSocket libraries, and then you could have those messages coming in and out of Pulsar, and that's not too much of a rewrite since they're kind of REST anyway, but over WebSockets. That might be the easiest. I would recommend, though, if you're looking at moving to an asynchronous path, take the business logic out of there, put that in a class that lives by itself, and then have an interface runner that calls it. Like here, put it in a separate service that anybody can call, and then maybe it's connected to Pulsar, maybe it's connected to synchronous. So you could run them both at the same time for a while until you're ready to maybe make that the jump to all asynchronous, because then you might decide maybe I can run this all as Pulsar Functions, or maybe I should go to Spark or Flink or something else. There's a lot of different options out there, but keeping that business logic not tied to the interface, very helpful for you for lots of reasons. So if you could pull the important parts out, that way you could try both mechanisms and without being tied to one implementation of that. Does Pulsar have the concept of priorities? We have both that. Yeah, you could change how messages go with, you could speed some up with priorities. There's some of that ability to speed up routing. Though remember, the difference between Pulsar and Rabbit is that's not as much of a concern because Rabbit tends to be one node. Pulsar has multiple. And with the broker layer separate from the storage, I'm processing a lot faster. So that may not be an issue where you see it like, oh, and since we support so many topics and namespaces, put the batch ones over here, maybe, send them on a timer in a batch. Other ones happen so fast. Yeah, you can set priorities, but really, I don't tend to see people do that because it's not required, because Pulsar is a server that spreads out to as many nodes as you need. So, if it's trillions of transactions a second, it's not tied to one big server like some of the other messaging things are. So, yeah, you're not going to see that issue. We see a lot of people move from Rabbit to Pulsar because of that when you hit a certain wall of size.
I think the call might be about to end. I'm sorry, I didn't want to cut you off.
Yeah, no problem. And we'll post something on that Rabbit interface for you, so you'll have all the details there.
Tim, thank you so much. Greatly appreciated.
Yeah, no problem. Thanks for having me.